Welcome to the UN Brief. Today we interview Mark Ferguson. He is the chair of the European Innovation Council and was until recently the chief scientific advisor for the government of Ireland. Thank you so much for watching and listening to the UN Brief, and don't forget to subscribe. How are you? It's good to see you.
I'm well. How are you?
Very well, very well. So I know you are in semi-retirement. No, you're just no longer with the Science Foundation of Ireland.
That's right. My 10-year term of office finished in January of this year. So 10 years is the maximum allowed by the legislation. And that coincided with me being 66. So I have retired in inverted commas, but I'm still chairing the board of the European Innovation Council, and I'm doing some other board work.
Right, so that's what I hear, right? So you are very active, no retirement at all for you, I imagine.
Exactly,
Most
exactly.
people work in research, don't feel like they should retire or they
That's right. That's right.
In any case, because that's the kind of thing that you have a lot to offer the more times goes by, right?
Exactly right. Exactly
Experience counts in that matter. So what I would like to do today is a short interview on about what is happening, at the European Innovation Council, what you have planned for the rest of 2022 or 2023, if you want to talk about that already, and a little bit about your career.
Okay.
Your research career is very interesting. I remember when we first met at the European Commission high-level group of experts that you were already talking about you were talking about your research in a very exciting manner. So tell us a little bit, Mark Ferguson, really a pleasure to have you at the UN Brief. Welcome.
Thank you.
So tell us a little bit, how was your career arc? Tell us a little bit, what was your first passion in science?
Very good. So I started as a dentist. So I went to university and I qualified in dentistry. But in the course of that, I took a year out to do a science degree, and I became really interested in research in a birth defect, cleft lip and palate, where the baby's born with a hole in the roof of its mouth. And I researched that. And then I worked on alligators and crocodiles, like this animal which is on my background. And the reason for that is that alligators and crocodiles develop in an egg like a chicken, and they have a roof of their mouth like a human. So you can do all kinds of interesting experiments. And in the course of that, I became an alligator biologist. So I discovered a phenomenon called temperature-dependent sex determination. So if you incubate alligator eggs at 33 degrees, you get all males. And at 30 degrees, you get all females, and in between different sex ratios. That's now been known, in about 800 species of reptiles. It's quite common. And I also discovered if you operate on an alligator embryo, it heals without a scar. So scarring is a big problem, like burned children or road traffic accidents or trauma. So we investigated the cell and molecular biology of scarring and scar-free healing. And then on the basis of that, developed pharmaceutical drugs to try and improve scarring. And so with my wife, Sharon O'Kane, I co-founded a biotechnology company of which I was the CEO. It was called Renovo, developing pharmaceutical drugs to prevent scarring. And that company went up and down like biotech companies do. And eventually it was sold in a hostile takeover bid in the London Stock Exchange. And then I moved to be the Director General of Science Foundation Ireland and the Chief Scientific Advisor to the Government of Ireland, and looking at broader policy things in a company. So that's a sort of potted history of my career. It sounds very disjointed, like, alligators and dentistry and government science advice, but there is actually a connecting theme.
There is a connecting thing, which is your curiosity too, and your ability to connect dots, right? Again, to look at different disparate fields of information and make sense of it and discover new things. That's what makes researchers, right? I think
Absolutely.
the very core. And you have worked also now lately, you've been working with the European Commission, with the European Innovation Council. Tell us a little bit about what is the European Innovation Council for those in our audiences who are not familiar with that part of the European Commission, and what does your work entail?
Very good. So the European Innovation Council is a really important new instrument in the Horizon Europe budget. So basically, I chair the board of the European Innovation Council, a very distinguished board. And this is a new instrument, and it's really focused on trying to encourage high-tech businesses in Europe to grow and scale. So if you compare Europe to the United States or to China, we're pretty on a par with the science. The science is about equal in the United States, say, versus Europe, if you look at numbers of publications and quality of publications. If you look at numbers of startups, it's about on par. But where there's a huge difference and Europe really lags is in the scaling of those companies. We don't have the European equivalents of the Microsofts and the Facebooks and so on. So the European Innovation Council is about trying to address that gap. And it's got three very simple programs. The most important program and the novelty of the EIC is the accelerator program. And for that, a company anywhere in Europe or any country that is associated with the European programs can apply and get up to 2.5 million euros in a grant and up to 15 million euros in equity. That 15 million euros in equity will probably rise to about 30 million euros in equity. Now, the European Innovation Council wants to crowd in other investors. So we really want to work with other people. So we want to crowd in private investors. We want to crowd in national funds, sovereign wealth funds, essentially anybody to invest in these high-risk deep tech companies. And so we do that by putting in our money, and the aim is to leverage that between 3 to 5 to 1. The board has actually set a target of 5 to 1. So for every euro we put in, we'd like to see 5 euros from other sources. At the moment, and there's been a 3-year pilot, it's about 3 to 1, and that's pretty good. 3 to 1 is average. 5 to 1 would be top 5% in the world. So what that means is that the budget of the European Innovation Council, which is 10 billion euros, if you leverage that 5 times, then you bring in an additional 50 billion euros, which makes it 60 billion. But I mean, the gap with the United States is in the hundreds of billions, but this will go some way towards addressing that gap. And it's about trying to de-risk the investment. It's about trying to encourage other investors to come in. It's really about trying to scale the business properly. For example, a few weeks ago, we made an investment in a French company called SI Pearl. This is developing chips for supercomputers. It did a Series A round of 100 million euros, and we put in 30 million euros from the European Innovation Council. If we hadn't put that in, it would probably have ended up raising maybe 30 or 40 million euros. That's the kind of European disease to underfund. And what that means is the company doesn't scale quickly enough. It doesn't scale and therefore it becomes uncompetitive and doesn't grow like the competitors. So that's the aim. There was a 3-year pilot, and in that 3-year pilot, we made about 160 investments. We deployed about 3 billion euros of European taxpayers' money. And of the companies that have been invested in during that time period, about 10 of them are now unicorns worth more than 1 billion. 100 of them are worth more than 100 million. And then there's a whole tail of other companies. So, you know, it's working. There's a lot to do. It's new. There have been teething problems because this is the first time the Commission has ever taken equity, but we're getting through those. And the real hope is that this will really energize the European deep tech. So this is really about health. It's about digital. It's about climate change. It's not about butcher shops and bakeries. You know, it's about deep tech. It will really energize the European, and hopefully we will have world leaders in, for example, climate change.
Indeed, indeed, because that is one major issue that we need to address, right? And the president has spoken about this. And there is also the Green Fund, right? You have many initiatives. So tell us a little bit about the companies that became unicorns. Tell us a little bit about their journey and how they were. How did you get interested in investing on them? What kind of qualities you saw in the companies?
Absolutely. So, I mean, I think if you look at all of the investments and indeed the unicorn companies, in simple terms, they're split into three broad categories. One is health. So that's everything from vaccines through to pharmaceuticals to new ways of delivering health, like, remotely. About a third of them are in digital. So this is all kinds of things, whether it's digital fintech, whether it's digitization of industry, better ways of manufacturing, supply chain, whatever. And about a third of them are in the broad issues of climate change. And I think that there, particularly in the climate change, there are huge opportunities. So this is not just things about, for example, energy storage or new forms of batteries or managing the grid. It's about using, for example, carbon dioxide as a substrate, using carbon dioxide as the starting point to manufacture important products, whether they be plastics or whatever. It's about different ways of capture and storage. It's about different forms of concrete. It's about, for example, air conditioning will become much more important. I mean, it's already important in many European countries, but with climate change, it will become even more important. And air conditioners, currently use gases that are not very pleasant for the environment if they're released. They're refrigeration gases, so they trap the warmth. And they're also very carbon intensive. But there's new technologies like solid state technology where, in simple terms, you either have ordered or disordered molecules and there's no gaseous phase. So these are things that would absolutely revolutionize on a global basis. And many of these technologies are at an early stage. So they are just about commercially viable, or they are commercially viable. And of course, like everything, they proliferate, they really go quicker. Quantum, we've invested in a European quantum company. Quantum is going to become very important. Quantum computing, for example, will be very important. And that's also a cat and mouse game. Quantum computing will allow quantum computers essentially to crack most of the current cybersecurity algorithms. But then we also have companies that are developing quantum resistant protection or encryption. So as one technology develops and disrupts the market, so another one comes in and
another field opens up. It's like cybersecurity now. We need it even more, right? The
absolutely.
Applications and digitalize the economy, the more we need cybersecurity tools.
That's true. And quantum will make a big impact there, both in terms of a threat, in inverted commas, where you can overcome most of the current algorithms, but also in terms of new developments. So I think it's very exciting. And one of the really interesting things is that, particularly in the whole sphere of, CO2 utilization, this is a virgin field. I mean, there was really no pressure to use carbon dioxide as a starting point for a building material or substrate. 10 years ago, people were quite happy with all the things. So there's a lot of low-hanging fruit. And I'm very, very optimistic. I mean, the real hope, and what we hope in the European Innovation Council, is that we can build European companies that have a real global impact, that are like the current day Microsofts or Amazons or Facebooks or whatever, but that these companies are addressing real societal challenges like climate, like health, and so on. So, the current wave of those big tech giants, they're really about, selling, or they're about advertising, or they're about sharing photographs and messages. And whilst those things are important, like, there's a huge opportunity to do other things. So I'm very positive, and I think this plays to traditional European values. I think the traditional values of health and looking after the earth, but also, values of traditional engineering. It's where the digital world meets the physical world, where you need real physical skills in civil engineering and mechanical engineering, as well as the digital stuff. So I'm very hopeful. I mean, lots of people can be very negative about Europe. I'm not one of those people. I actually think that there are huge, huge opportunities, and I think there's huge opportunities for global collaboration. So that's what we're trying to do. We're trying to catalyze that. We're trying to work with people. We're trying to crowd people in. And I always say, our aim is to make ourselves redundant. In 10 years' time, if we're so successful, then we won't need to catalyze it, because all of the world's investors will say, hey, we have to look at Europe because that's where all the interesting things are, and that's where people are making lots of money and so on. So that's the aim.
Yes, we have seen venture capital moving to Europe much more in the last year or so, right?
Absolutely.
Some venture capital firms from the US are coming here because they realize there is great potential indeed, because as you said, academic centers of excellence, universities, institutions that really produce the finest researchers, and instead of having them go away somewhere else because it's more attractive, if they have a way to stay here and be able to continue the research and even develop companies too that can become unicorns, as you said. So to wrap it up, in terms of the medical research and the medical commercialization of research, what do you have on the pipeline, or is there any company that you want to mention in particular that you have invested on in the last 3 years in the pilot phase, or is anything you're going to be looking towards in the next quarter and the next year?
So there's a lot of things happening in the medical sphere. So vaccines are obviously the flavor of the month with the success of COVID, and that was a huge European success. A lot of the messenger RNA vaccine technology came from Europe with BioNTech and so on. So vaccines for a number of things. Obviously, pharmaceutical drugs remain extremely interesting, people looking at different targets, but more and more the application of artificial intelligence to medical systems. So artificial intelligence, for example, for diagnosis, training artificial intelligence systems, for example, on cardiac arrhythmia data sets, on the kind of data sets you might get out of a modified Fitbit, or digital watch or a digital application. So there's a number of applications there that I think will become very, very interesting, because they will not only allow the doctor or professional to monitor the patient's health, but the person himself or herself will have an aid to interpret the data, which at the moment is looking as good as the best professional. So a lot of artificial intelligence as applied to the healthcare sector, also in terms of mining to try and find new targets. Quite a lot of stuff about how you deliver healthcare services. So remote telemedicine, for example, remote allocation of resources. I think there's a huge area in the brain and mental health. So really trying to get companies, using monitoring technologies, non-invasive monitoring technologies to monitor people's therapy for mental health, also to monitor people learning, for example, seeing changes in brain waves and structure, looking at interventions that may be important there. So, there's a vast amount still to do in that sector. And of course, it's become very interesting, and the public have become very interested because of the huge success of the COVID vaccines. I mean, that's really shows science and innovation at its best. Who would have thought that we would have been able to develop vaccines in a fraction of the timeline? Who would have thought that an untested technology like the messenger RNA technology would have proved so efficacious and actually so safe and been done very rapidly? So that's kind of made everybody think there are ways that we can develop things safely and effectively that are much quicker than they were before. And that's a kind of important mindset. So health will always be very important for people. Aging, everybody wants to age well. I mean, some people want to live longer. Most people want to live a full life and then kind of die spectacularly without a lot of suffering. And so ways in which you can address aging more in terms of preventing the chronic illnesses around aging, massive opportunities.
Thank you for watching and listening to the UN Brief, and don't forget to subscribe.